Hey, Math 2 students, Unit 2, Assignment number 3, Notes, which, if you're following along and you're writing this down, and you should be, you can see that you are going to be in your packet on page 9. Okay, so the first thing is, let's go over if-then statements and identify which part of the if-then statement is what we call the hypothesis and which part is what we call the conclusion. So, and as you can see down below here, there are 3 statements which we call if-then statements. And the reason why they are if-then statements, because in each statement you see that the sentences start with the word if, and then there's some information, then somewhere you see the word then. Okay, so the very first statement, if you are a fish, then you can swim, is what we call an if-then statement. Why is it an if-then statement? Simply put, because it has the word if and it has the word then in it. The second sentence, if a shape has 4 sides, then the shape is a quadrilateral. And then the third sentence, if a triangle has 2 congruent sides, then the triangle is isosceles. Okay, so now what we want to do is we want to identify which part of this if-then statement is what we call the hypothesis. And I will always outline the hypothesis in blue. And we're also going to identify which part of the if-then statement is the conclusion. And I will identify the conclusion in green. Okay, so in the first sentence, if you are a fish, then you can swim. The hypothesis is you are a fish. Then the conclusion is going to be you can swim. Okay, it's that simple. So if you notice, when we look at these if-then statements, the hypothesis is the part of the sentence or the piece of the sentence immediately after the word if up until then. Then the conclusion is the piece of the sentence which is immediately after the word then. Okay? The hypothesis does not include if. The conclusion does not include then. So please do not say the hypothesis would be if you are a fish. That is wrong. The hypothesis is you are a fish. The conclusion is you can swim. Don't include the word then. Okay, so in the second sentence, if a shape has 4 sides, then the shape is a quadrilateral. The hypothesis would be the shape has 4 sides. The conclusion would be the shape is a quadrilateral. Okay, in the last sentence right here, if a triangle has 2 congruent sides, then the triangle is isosceles. The hypothesis would be a triangle has 2 congruent sides. The conclusion would be the triangle is isosceles. All right, so there we have the if-then statements. Now, every if-then statement has what is known as a converse statement. So what we're going to do here is we are going to do 2 things in this problem. Okay, so number 1, we're going to write the converse of each if, then, above. And 2, we're going to determine if the converse is true or false. Okay? All right. So, let's write the converse, first of all, of the if-then statement. If you are a fish, then you can swim. Here's what the converse is of that statement. If you can swim, then you are a fish. Okay? So if you notice, what I did was to write the converse of that very first sentence up there, I just switched the conclusion. I made the conclusion the hypothesis, and I made the hypothesis the conclusion. Okay? So basically, when we write the converse of an if-then statement, what we're doing is we're switching the if and the then. All right? So the converse statement is simply the process of switching or changing the if and the then. Okay? So that's all you're doing when you're writing the converse, switching the if and the then. You're just reversing them, or not reversing them, but you're changing them how you write them. Okay? So let's go to the second sentence, and then we'll go back to the first sentence, and we'll determine if that converse is true or false. Okay? So the second sentence, if a shape has four sides, then the shape is a quadrilateral. The converse would be if a shape is a quadrilateral, then the shape has four sides. Okay? The third sentence, if a triangle has two congruent sides, then the triangle is isosceles. The converse of that would be if a triangle is isosceles, then the triangle has two congruent sides. All right? So there we go. That's how you write the converse. Now, let's go through each sentence one by one, and let's determine if the sentences are true, determine if the converse is true or false. Okay? Now, if you say that it's true, what you're saying is that it's true 100% of the time. Okay? In other words, there does not exist an instance or an example that would contradict the sentence right here. Now, if you say that it's false, what you're saying is that there exists one or more examples that contradict the converse. Okay? And the word contradict means that it goes against what the converse is saying, that contradict the converse. All right? So let's go through this right here. If you can swim, then you are a fish. Is that true 100% of the time? Or can you think of one or more examples of something that can swim that is not a fish? Okay? Is there something in the world that can swim that is not a fish? All right? Of course there is. There's lots of things, okay? So this statement would be false. And the reason why it would be false is we can come up with many examples, okay? Here's an example. My dog can swim. My dog is not a fish, but she is an amazing swimmer. So that would be false. If you can swim, then you are a fish. That's false. My dog's not a fish, and she can swim, okay? Let's go to the second example right here. If a shape is a quadrilateral, then the shape has four sides. Is this true or false? Okay, so first of all, what is a quadrilateral? Well, a quadrilateral means that it has four sides. So if you have a shape that's a quadrilateral, that means it's a four-sided shape, then the shape has four sides. This is true. There's 100% of the time that this is true. So what we're saying is that every shape that's a quadrilateral is always going to have four sides. Okay? The third sentence, the third converse, is this true or false? If a triangle is isosceles, then the triangle has two congruent sides. Is that true or false? The answer is this is true. And the reason is because the word isosceles, every triangle that's isosceles, that means it has two congruent sides. So 100% of the time, an isosceles triangle is going to have two congruent sides. Okay? All right, let's go to substitution to solve a system of equations. Okay? So first of all, let's make sure we understand what a system of equations is? So a system of equations is any set of two or more equations that have two different variables in each equation. Okay, here's an example of what I mean by that. Any set of two or more equations that have two different variables in each equation. Here's the first example right here. Y is equal to 4x plus 3 and y is equal to 3x plus 11. Okay, this right here, number one, notice I have how many equations do I have? I have two, so that is a set of two equations. And do each of those two equations have two different variables? The answer is yes. Each equation has a variable x and a variable y. Okay, now you could actually have a system of equations where there's 3 equations or 4 equations. We will, in this class, only work with equations that have system of equations that have 2 equations. Okay, and what we're going to do is we're going to use a method called substitution to solve this equation. And when I say solve the equation, what I'm asking you to do is to tell me what is x equal to and what is y equal to. Okay, so the first thing that you notice is that both of the equations are equal to the variable y. Notice that. Both of the equations are equal. The 4x plus 3 is equal to the variable y. The 3x plus 11 is equal to the variable y. So what that tells me is that the two equations, the 4x plus 3, is equal to the 3x plus 11. Because both of those equations are equal to the same variable y, that means that they're equal to each other. So we create the equation 4x plus 3 equals 3x plus 11, and then I solve this equation to solve for x. So I'm going to subtract 3x's from each side of the equation. 4x's minus 3x's is x. I bring down the plus 3. I bring down the equal sign. I cancel out the 3x's. The minus 3x cancels out the positive 3x. And I bring down the positive 11. And then my next step would be to subtract 3 from each side. And I get x is equal to 8. Okay? Now, that right there is half of your answer. All right? That's 50% of your answer. And the reason why that's only 50% of your answer is because I still need to solve for y. Okay, so once I find x, and by the way, sometimes you find y first, but once I find x in this case, what I'm going to do is I'm going to go back to one of these two original equations, and I'm just going to go back to the top equation, and I am going to substitute the x equals 8 into that equation. So instead of y is equal to 4 times x plus 3, I get the equation y is equal to 4 times 8 plus 3. Notice I substituted in the place of x the value 8, because that's what x is equal to. 4 times 8 is 32. 32 plus 3 tells me that y is equal to 35. Okay, so for this example, example number 1, my x value is 8, my y value is 35. All right, example number 2, let's do one more where we're solving a system of equations. So I have y is equal to 11x minus 7. My other equation is y is equal to, let's go ahead and make it 8x plus 29. Okay, so if you notice, just like in the previous equation, both of these equations are equal to the same variable, and the variable is y. Okay, so what we're going to do is we're going to use the substitution method. So because both the equations are equal to the variable y, that tells me that the two equations, I could take the 11x minus 7 and I could substitute it in the place of this second y here. So I would get 11x minus 7 is equal to 8x plus 29. Okay, and the reason why I could put that 11x minus 7 in the place of that y is because 11x minus 7 is equal to y. Okay, then I use algebra to solve here. So I would subtract 8x's from both sides of the equation. 11x take away 8x is 3x. I bring down the minus 7. I bring down the equal sign. The minus 8x would cancel out the positive 8x, and I bring down the 29. Next, I would add 7 to both sides of the equation. I would bring down the 3x. The positive 7 would cancel out the minus 7. I bring down the equal sign. 29 plus 7 is 36. And now I would divide 36 by 3. And I would also divide that 3 by 3. The 3's would cancel each other out. And I would get x is equal to 12. Okay, so that is what x equals. Now remember, that is just half your answer. Because my system of equations also has a y in it, I am going to take that x equals 12, and I'm going to substitute it back into either one of these equations. And for the second example, I'm going to substitute it back into the second equation. Okay, so my second equation is y is equal to 8x plus 29. Now, fun fact, it does not matter which value you which equation you substitute the 12 back into. Both of them will work out to give you the same value for y. Okay, but in this case, I'm substituting 12 in the place of x. So my equation becomes y is equal to 8 multiplied with 12 plus 29. 8 times 12 is 96. 96 plus 29, that gives me y is equal to 125. So solving this system of equations out, I've just figured out that for either equation, x is equal to 12, which would make y is equal to 125.